Hi Vegas students, this is my test run on this. Here I have an example of two figures. One of them is polygon BCDEFGH and the other is a polygon that's been obtained after a couple of rigid transformations. What I want to see today is if we can figure out how to use some of our basic rigid motions, so our reflections, rotations, and translations, and determine how to transform this shape on the left to the shape on the right. Anytime we are able to do this, to use a sequence of rigid motions in order, some order, in order to get one shape to map onto another, we are going to call that a congruence. And we will say that shape BCDEFGH here is congruent to shape, oh gosh, I can't even say it, the one with all the primes, the shape on the right. To help us keep track of each of the shapes as we go along, I'm actually going to set the color on these. So I'm going to use my select tool, and I am going to use the settings to change the color here, and that's just so I can track. Okay, now that we've done that, let's do our first movement. What we saw in the video that transformed the one H shape onto the other is that often it helps to start by lining up 2 points. So I noticed that these two shapes seem to both have the part like BCD. It's pointing upward in both cases, although as a reflection of one another. So I could make a choice to just do a reflection first, but I don't know what line to reflect over. I have a sense in my mind that what needs to happen is that I need to reflect this so that this B point is more over on the right-hand side of the image, but I don't know exactly, is it a complete perfect vertical line that I need to reflect over, and what line would that be? So often the best first step that will allow me to do this in the shortest number of moves possible is to start by translating this figure so that one of the points on the green figure is aligned with its corresponding point on the right figure. So I'm going to do that. If I go into, is this the one? I gotta find it. I think. Ooh. Let's look till we get there. There we go. This is the one that has the things I want. I'm going to choose Translate by Vector. It's the same tool we used in that other app. I'm going to select the entire shape, and I'm going to translate point F onto point F double prime. And I'm doing that because I see they're both the points with that narrow angle there. It looks like it's only 45 degrees, and it's the only point I see in the shape that has that small 45-degree angle EFG. So now, after mapping along this vector from F to F double prime, notice that creates a new shape, and now we can see that it isn't aligned exactly right with the shape on the other side. They're not just perfect reflections of one another, there's something else getting in the way. So if I could find the line of reflection that went right down in between them, then I might be able to find the perfect reflection. But the easier way I'd have to do this is just by finding a way to rotate my new image a little bit until the FG segment aligns on both pieces. So there are two ways I could find the right amount. I could use a protractor, or in this case I can measure angles using this tool. So I can go in and I can measure the angle length of the angle G F double prime to G double prime. Now the reason I'm measuring that angle is that we know when we make a rotation, I have this point F, it's already aligned properly. I've made it so that particular corresponding point is already aligned. They correspond now from the original shape to my final image that I'm trying to get to. So I know that I need to treat that F as my center for my rotation, because that's the point that I don't want to move. Everything else is going to move, but that F and that F double prime point need to stay the same. because of that, what I then do is look at any 2 points, and I want to look at the angle measure between them. Well, I had this sense that these two, the green on the left, or here, I'll give it a new color. Oh, whoops. Let's undo that. Let's go to the arrow tool. And let's select this and give it a different color. There we go. So the pink shape to the blue shape, if I could figure out how much to rotate, what that angle size is between these, then by rotating this whole figure by exactly that amount, which we see here is this angle beta, which is 22.7 degrees. I know it's a little hard to see there. Then if I rotate exactly that amount, I'm going to have the perfect rotation to put that G prime 1 point on top of the G double prime point. And that'll align these other 2 points that I know I want to correspond. So I found the angle measure because I would do that with a protractor if I was doing this on paper or with plastic, because I know I want to rotate from point F, I want to rotate the whole image, and the size of the rotation is exactly the size between a particular point and what its image point should be on those 2 corresponding rays. So let's do that rotation. Okay, so I'm going to go in again to this one that's here for transformations, but I'm going to pick rotate. And I'm going to pick my shape and my center, and we checked that was 22.7 degrees, I believe. I want to rotate counterclockwise. How do I know it's counterclockwise? Well, I'm starting with the pink figure, and so if I'm rotating counterclockwise, that would move the pink figure towards the blue figure, because that would go in the opposite direction that the hands on a clock move. So let's do that rotation. Great, do you see now? It's a little hard to see. Let me change the color of this last image here, and let's change its color so we can more clearly see. Okay, so the brown one is the image after the rotation. It's the one that now has letters K, M, N, G, etc. on it. And we can see that it lines up now not just that point that we had that was point F, but now we've also lined up the point that had been point G with its image. So now if we look at these two, we can see that the point M corresponds to this point D, N corresponds to this point E double prime. It looks like everything is aligned so that if I were to reflect over this line that goes between these 2 points, if I were to reflect over that line, I see perfect symmetry, and I believe that that last reflection now will line the 2 shapes up. So this should work anytime. If I translate, then rotate, either that'll be enough to make the 2 shapes the same, or I might have to reflect as well, like I do here along some axis in order to get them to align. So let's do that reflection last but not least. I'm gonna take my reflect tool, I'm gonna select my shape and my line. And yep, now we see that we did land right back on top. So let's observe how that worked so well. I'm going to go back through the steps. So I'm just going to click the back arrow. We'll make everything disappear. Okay, so we have our original shape, and in the figure that I am claiming is congruent. So the first thing we did is we noticed, well, if I could move point F onto F double prime, and I did that by a translation. Now I've gotten the 2 shapes close together and I can orient them the same. The next thing I did was I figured out how large is the angle between the other end of the segment on the same segment as that center point, so they could figure out how to lay them on top of each other. And I used a rotation by that amount to get the brown figure. And last, I reflected over the line. Pretty cool, huh? This is a great example.